Okay, let's look at some examples. So here's a question. How much energy is needed to melt 25 grams of platinum if you're so rich? And it starts at a room temperature, which is 20 degrees Celsius. So you will be given that on the problem on the test, or you can always look it up. So say Cp of platinum is 0.13 joules per gram per degree Celsius. That is how much energy, 0.13 joules, you need to increase the temperature of 1 gram of platinum by 1 degree Celsius. And you need to go all the way from 20 degrees Celsius to 1770 Celsius. So that is 1750. So 1750 will be your change in temperature. And it's not 1 gram, but 25 grams. And that will only bring platinum to the boiling point, to the melting point. And after that, you are going to have to melt it, which also takes energy, and it takes 100 joules per each gram. So see, this is 0.13 joules, but that is just to raise the temperature of 1 gram, and 100 joules is to completely melt 1 gram of platinum. So we have two processes taking place here. So our total energy is going to consist of two Qs, Q1 and Q2, and if we draw the graph, the first process has to do with change in temperature. So if this is our temperature, it's rising, and it's rising from 20 to 1770, the change of 1750. And then you have the melting part. In the melting part, there's no change in temperature. That's your phase change. You are not speeding up the molecules, you're just tearing them apart, and you're turning your kind of structured solid into something that is liquidy and flowing. And anyway, so when you're dealing with the change in temperature, the formula that you're going to be using is Cp delta T, which we've been using all this time. So 25 will be your mass, Cp is 0.13, and then change in temperature, I already said, is 1750. And then the flat part, that has to do with latent heat of fusion. It's called latent because we are putting energy in, but we don't see any increase in temperature. That's why it's called latent. And in Latin, it means hidden. Anyway, so we are kind of putting that energy somewhere, but we do not see any change in temperature. So our Q2, this should be Q2. So LF, which is latent heat of fusion, it's 100 times our 25 grams. So we figure out Q1, so that's Cp m delta T, and then we do Q2, which is latent heat of fusion, times the mass, which is 25 grams. Once you find these two numbers, just add them together, and that's it. Now let's look at another example. Say we have a certain amount of energy that we can invest into melting aluminum, and we need to figure out how much aluminum we can melt with that amount of energy. And the latent heat of fusion of aluminum is 398 joules per gram. When you deal with something that is melting, the first thing you're checking is it already there? Is it already at the melting point? And it says assume that it is at the melting point. So all you need to do is just latent heat of fusion, which is 398, and you multiply it by, you don't multiply it, you're looking for mass. So you know Q, you know LF, and you're looking for mass, so you just do Q over latent heat of fusion. So in our numbers, it's going to be 1300 divided by 398 grams, and that's it.